In discussions of science and the Bible, often the topic of the age of the earth comes up. And a common scientific test for finding the age of rocks is radioisotope dating. The Bible seemed to indicate an earth that is only 5,000 or 6,000 years old, whereas the radioisotope methods seem to indicate an age of about 4.5 billion years. So, can these be reconciled? Or is one right and the other wrong? Let's examine. There are several types of radioisotope dating. The idea is that a parent element isotope undergoes nuclear decay to a daughter element isotope, and that by measuring the amounts of the isotopes, you can estimate the age. One common method is potassium-argon dating, which is used on volcanic rocks, which used to be liquid lava. The assumption is that when the lava was flowing, most of the extra argon gas that was present would have escaped, so when the rock hardens, little argon remains, only the amount present in the atmosphere. Next, the potassium present in the rock would likely have several different isotopes or varieties of the potassium atom with different weights. One isotope, potassium-40, is radioactive and slowly decays to argon-40 and calcium-40, with half of the amount decaying each 1.3 billion years. So by measuring the amount of potassium-40 and argon-40 in volcanic rock, we can supposedly find the age of the rock. There are actually three key assumptions built into this. First, an assumption of the constant speed of decay over the centuries. Second, starting proportions that are assumed to be known. And third, an assumption that there was no addition or removal of either element over time. Interestingly, all of these assumptions have been known to sometimes have been violated in some situations. Regarding the decay rate, factors such as temperature and chemical environment have been shown to change the decay rates of some elements. See the supplement for details. Regarding addition or removal, it turns out that elements can often be dissolved or precipitated or moved by fluids passing through the rocks. And finally, regarding the starting proportions of the elements, we can deduce that these must have been different than expected due to wildly mistaken dates for known volcanic events. For example, the Mount St. Helens volcano erupted in 1980 through 1986, and in 1996, some rocks collected from the 1986 eruption dome were dated by secular labs through the potassium-argon method. The results from the lab showed an age of somewhere between 350,000 years to 2.8 million years, depending on which mineral inside the rock was used, for those rocks which had only solidified 10 years earlier. In this case, it's easy to see that some excess radioactive argon must have been retained in the lava as it solidified. But we can only say this because we already knew beforehand how old the rocks were. Similar errors have been documented for volcanic rocks from Hawaii, New Zealand, Sicily, and other parts of the world. An important question to consider with these methods is, why should we trust dates from rocks of unknown history if the methods are not trustworthy on known rocks? See the links in the details. Scientists have come up with another set of radioisotope dating techniques called Isochron methods. The basic idea is to take multiple measurements of different parent-daughter element pairs in a rock sample and use the multiple measurements to get a more reliable age. We could take multiple different minerals from the same rock, which gives what's called the mineral isochron, or several samples from the rock without separating the different minerals, which would give the whole rock isochron. The first step is to measure the isotope ratios and compute the age from all the samples using the basic radioisotope assumptions. Then if we plot the multiple measurements on a graph, aligning them based on how much of the parent element isotope each contains, then if those points make a nice straight line on the graph called an isochron line, that age is considered reliable and can be computed from the slope of the line. If the points are scattered all over the place and don't fit a line model, then the date is considered unreliable. However, these isochron dates have been shown to conflict with each other when used together on the same rock, often differing in their dates by millions of years, even though the narrow isochron lines seem to imply high accuracy for those samples. So the isochron dates can't all be correct. One explanation for the discrepancy is the mixing of the lava with other rocks as it flowed up and came out of the volcano. Mixing can look identical to isochron lines, and there's no way to tell them apart by looking at the isotope ratios alone. See the supplement for links with more information about this. Another refinement of the isochron approach is the argon-argon method. This method exposes a sample of the rock to a controlled amount of radiation from a nuclear reactor, which turns some of the potassium-39 atoms into argon-39. Next, the amount of argon gas in the sample is measured by heating it in controlled steps and measuring how much argon-39 and argon-40 isotopes escape at each step. From this, we can estimate both how much potassium is present in the rock, the parent element, and how much argon is present, the daughter element, from normal age-related radioactive decay from potassium-40. Then, scientists check whether the ratio of argon-40 to argon-39 coming out of the rock is the same at different temperatures or different. If it's different, that would supposedly indicate that there was some anomaly in the rock, metamorphic or heating episode earlier in the rock's history. If the argon levels are similar at all temperatures, that supposedly indicates that it's a good, reliable date. However, there are several problems. First, argon-argon isochron dating needs to be calibrated against a sample of known age to make the calculation work. So when secular scientists use a sample that has been dated by other methods to allegedly be millions or billions of years old to calibrate an argon-argon isochron date, the new isochron date is no longer independent. Second, just as with the other methods, there are serious discrepancies seen between the dates, showing that not all the dates for these rocks can be correct. Some creationist scientists have written that multiple lines of evidence point to an accelerated rate of radioactive decay in the past. From 1997 to 2005, studies were conducted in a project called the RATE project, which stands for Radioisotopes and the Age of the Earth. Here are the evidences they found. First, zircon crystals have uranium inside, and as it decays, it produces helium, which eventually leaks out. The hotter the rock, the faster the helium leaks out. The RATE group looked at zircons found in deep rocks, which showed by standard uranium-lead dating that they had experienced millions of years of radioactive decay. However, when the helium was measured in careful heating steps, there was still so much helium trapped inside the crystals that they could only be a few thousand years old. So this was interesting. One radio dating technique gave millions of years as the date. Another technique gave thousands of years. Second, the RATE group looked at carbon-14 dates for carbon-bearing rocks like coal and diamonds. With carbon-14 dating, there should be no detectable carbon-14 left in materials that are older than 100,000 years. However, the experiment showed that even though these coal lumps and diamonds were supposedly millions of years old, they still all contained detectable carbon-14 in them, again showing that they couldn't really be that old. It's an interesting fact that, to my knowledge, all coal, all natural diamonds, all dinosaur bones, everything and anything that potentially could be dated with carbon-14 dating still has carbon-14 remaining in it, showing that none of these items could be more than 100,000 years old and quite plausibly much younger. The global flood would have suddenly changed carbon ratios on the Earth because of burying a huge amount of organic material, which was turned into coal and oil and gas. So by suddenly removing a lot of carbon-12, while the sources of carbon-14 in the upper atmosphere remained the same, this would have had the effect of making today's ratio of carbon-14 to carbon-12 higher than the ratio before the flood. This would make flood fossils' carbon-14 dates to seem older than they actually are, by about 40,000 years. Third, the RATE group looked at radiohalos, which are microscopic rings inside granite rocks around clusters of radioactive atoms, like uranium and plutonium. They show that the damage that the nuclear radiation has done to the surrounding rock, kind of like burn marks. Rocks in granites associated with layers laid down by Noah's flood have a lot of these radiohalos, suggesting that there may have been a pulse of accelerated decay during the flood. They also found evidence that the radioactive clusters were moved by underground hydrothermal fluids, again supporting the flood account. Some of the plutonium isotopes involved have such short half-lives, less than 1 year, that it's surprising that any of these halos exist. They likely formed quickly, and when the first plutonium atom was formed by radioactive decay, it probably chemically caused other atoms around it to precipitate out of solution, which is why there was enough of them in a cluster to form the radiohalo, while the rock was still had hot fluids moving through it, but had cooled enough to preserve the halos. The polonium radiohalos, for example, some of which are right next to the uranium radiohalos, show a huge amount of damage, equivalent to 100 million years of radioactive decay of uranium at today's rates. However, since the polonium isotopes had such short half-lives, all of this decay must have happened within a few days or hours, to have concentrated that polonium at that focused spot before it could decay away. Some radiohalos are even squished in shape, showing that the radiohalos were quickly formed and then the rock layer was compressed by another rock layer above it while it was still relatively soft. Thus, the decay rate of the uranium seems to have been up to 1 billion times faster than at that time in history when those rocks were forming and cooling compared to today. Finally, in another set of experiments, the rate group sent rocks from several volcanic sites around the world to secular dating laboratories to use several isochron dating methods: potassium argon, rubidium strontium, samarium neodymium, and lead. They found many discrepancies in the dates from within the same rocks, sometimes differing by many millions of years, showing that isochron dates are not reliable in general. In conclusion, radioisotope dating seems useful for relative dates of determining where in the sequence of Earth's rocks various layers would fit, but in view of the many problems and violated assumptions, it does not seem accurate for absolute dates. So the widespread idea that science has proved that the Earth is 4.54 billion years old seems mistaken. Critics have tried to argue against this evidence, but the evidence and replies I've seen indicate that these are very strong arguments in favor of the 6,000-year-old Earth that the Bible describes. The Bible's historical record, including the origin of the Earth about 6,000 years ago, seems more reliable than these radioisotope dates. See the supplemental links for many more details.